So a few years ago, I was tweaking an alert as part of my job, and I accidentally triggered 772 help desk tickets. Twice. In 15 minutes. And the worst part was, I didn't even know I had done it until the entire NOC came up to my cubicle and invited me down to their area to help close the 1,544 tickets by hand. There was a mass close option, they wouldn't let me use it. So after a few years and some therapy, reflection, a little bit of alcohol, I can think back on that formative moment and ask myself really what went wrong. Like, was it the tool that let me do that? Was it the, operator? I mean, I think there's enough blame to go around, really, but I think at the end of the day, what it really was an immature understanding of what alerts are supposed to be. Let's see here. There we go. Ready? There we go. Oh, there's the once upon a time. There. So, thank you for coming to my talk, which is called Alerts Do Not Suck, Your Alerts Suck. My name is Adato. I'm a middle-aged white dude giving a conference talk. What else is there to know about me? Actually, there's nothing on the slide that matters, except that you can find me as Adato on almost all social media, and I did pick that picture so that you had a sense of confidence that I know what the hell I'm talking about. More importantly, you should understand that this is an oyster talk. Now, what I mean by that is that I only have 30 minutes. I cannot teach you anything in 30 minutes. In fact, in that amount of time, about the only thing I can do is irritate you. Now, when an oyster gets irritated, it does one of two things. It creates a beautiful pearl, or it dies. It is my sincere hope that I do not irritate you to death, but I figure that you should be forewarned. Instead, what I hope is that I give you just the grain of an idea that you will then think about and layer over until what you have is something that is polished and unique and personal and valuable to you. The SRE handbook defines alerts, and it says, wait, I have it written down here. I have to read it exactly. It is a notification intended to be read by a human and that is pushed to a system such as a bug or ticket queue, an email alias, or a pager. Now, not to blaspheme the Holy Scripture, but what the FSCK am I supposed to do with that? How does that make me feel like alerts are anything except useless and unnecessary? And the reason is that the SRE handbook has failed to do the most important thing. It has failed to give me a sense that alerts have any value at all. And ultimately, that's what this talk is about, is to give you a sense of the value that alerts can bring. Now, I'm not going to bury the lead. If you don't remember anything else from this talk, here are 4 points I want you to remember. First and foremost, email alerts intended to handle your incoming, email rules intended to handle incoming alerts are like assholes. Everyone has one and they all stink. If you have a rule in your inbox to handle incoming messages, you have already admitted defeat. You have no intention of dealing with that message almost ever. And the only time frame that actually is relevant to alerts is right now. That's the first thing. Second, welcome to this beautiful hill. It is the hill on which I am willing to die. It's called FYI Alerts Are Trash. Every time I have a conversation with somebody about an FYI, oh, well, I don't really do anything the first time I get the message, but after I see 4 or 5 in 20 minutes, then I know it's a real, hey, Sparky, I don't get paid by the bushel. How about I give you one alert when the thing has happened 4 or 5 times in 20 minutes? How about that? No FYI alerts. Third, I was about 8. I was visiting my grandmother. I looked at the Lipton soup box on the back. There's that recipe. And I said to my grandmother, look, there's a recipe. And my grandmother said something that is really not reprintable. It's in Ladino. To her, the recipe on the back of the Lipton soup box wasn't just not a recipe. It wasn't even a vague suggestion. The alerts that come with your monitoring or observability tool are not best practices. They're barely vague suggestions. They're really demonstrations of what the tool is able to do, and they give you a completely stupid example of if CPU is over 80%, look, you can get all the processes. Like, nobody wants an alert at 80%. Don't do that. Do not expect that the rules that are in your monitoring tool are considered best practices in any way. They're just examples. Fourth and finally, I cannot thank Charity Majors enough for coming up with this phrase, and I will do her the honor of giving the phrase as it was originally intended. Nines don't mean shit if your users aren't happy. Period. We have today something that we did not have when I started doing monitoring 25 years ago, and that is data about the actual user experience. And that is what we should be alerting on. First and foremost, if the user experience is degraded or impacted, that is what we should be alerting on. Everything else is secondary. Now, I'm not saying it doesn't matter, all those other things, CPU and disk and queue, locking and blocking and all that stuff, that's important, but those are very specific to certain teams at certain times. User experience is the thing that should get you and probably other people out of bed. So if you remember nothing else, there you go. Okay, for the rest of this talk, I'm going to give you ideas about how to make your alerts more valuable and why. I'm going to do it in 5 lessons. Lesson number 1, the fundamental nature of alerts. First and foremost, alerts are not the same thing as monitoring. Second, alerts aren't monitoring. And third, for the love of God, monitor everything. Monitor the crap out of your systems, but do not turn on every alert on every single thing you monitor. That is ridiculous. Okay. Alerts should be biased toward action. What I mean by that is, okay, every year your boss gets back from DevOpsDays Seattle with a brand new pair of socks and a shiny new monitoring system and hands it to you, and the first thing you do when you unwrap that sucker, the monitoring system, not the socks, is you create a CPU alert, right? Everyone does it. It's the first thing you do. I have a secret for you. CPU alerts are bullshit. High CPU isn't a problem. High CPU was never a problem. If I have a system that is running consistently at 98%, but it's getting all the work done and everything's being processed, you know what I call it? Very technical term, correctly sized. That's what it is. Again, bias toward action. Okay, some of you are probably sitting there, I just talked about CPU once or twice, right? And you're thinking, oh, here we go. Leon is old, and he's going to talk about, he's going to reduce everything down to CPU and RAM and bandwidth and disk utilization, which, is, old school grandpa monitoring, and completely miss the live experience that we have with microservices and containers and, all of that, and, metrics and events and logs and traces and stuff like that, with the fancy new observability, right? I see this a lot. I see conversations get bogged down with this a lot of times. It's not monitoring versus observability, it's monitoring and observability. The two are not mutually exclusive. So at this point, I want to detail a little bit about those differences and why. I'm going to draw a line on the slide. There it is. And I do so with the utmost respect for everyone who lost hair and stomach lining in the flame wars on Twitter about observability versus monitoring. And I want to be clear that the differences I'm outlining really are focused on alerting more than anything else. I don't mean any offense to anyone, and I do not want Charity Majors to come up here and eviscerate me on the spot. So let's talk about monitoring first of all. Monitoring is frequently focused on the known unknowns. That means I know this thing could break, I just don't know when. Again, disks can fill, CPU, blah, blah, blah. It also is focused on any cardinality, meaning how unique is this event, either individually or in combination, anything. Things that happen a lot, still good for monitoring. Things that happen rarely, okay, that too. Correlation is mostly manual because the systems are mostly domain specific. We'll talk about that in a minute. But really, I have to know that, oh, well, if this query on this system goes long and also CPU is high and also I see these other things, I have to know that because I have to have a good sense of what the system is all about. Okay, manual correlation. And finally, domain-specific signals. What I mean by that is that the things that indicate the network, routing and switching is bad are fundamentally different than the things that indicate that the application is bad, or the storage array is bad, or any of those things. Domain-specific signals. On the other hand, observability. It deals frequently and mostly with the unknown unknowns. I do not know what might go wrong, and I don't know when it's going to go wrong. It also cares mostly about high cardinality events, the really unique events. Again, either unique individually or unique in combination. Now, in combination is kind of hard because you usually have a metric ass ton of data, and therefore correlation has to be baked into the system because you get a lot of stuff coming in. And finally, it deals with sort of universal, or the so-called golden signals of latency, traffic, errors, and saturation. Those signals can apply across many different domains and are still relevant and indicate something is going wrong. Now, a little bit more about this. When you're talking about alerts and observability, I said there you have this metric ass ton of data, and usually to deal with that, you need to have a computer system, which a lot of people will say requires AI, which we all understand is a bullshit marketing term for 3-if statements in a trench coat. Joking aside, it's challenging to talk about something that complicated in a 30-minute talk. So when I talk about disk or bandwidth or whatever, it's not because the things that I'm talking about have no application to observability, but it would be difficult for me to give you relevant examples in any amount of time that would keep me long past happy hours. So I'm not going to do that to you. But I want to be clear that everything I'm talking about applies to both monitoring and observability and everything in between equally. Okay, back on track. Alerts have to matter, of course, to you because you're building it, but also to the people who are getting it. Okay, so what do I mean by an alert has to matter? Well, there's actually a simple algorithm. If and only if the alert is intended so that a human does something right now about a problem that is happening right now, then and only then is it an alert. All of those things must be true. If any of those things are not true, it's not an alert. Well, of course, that begs the question, well, but it's not a human, it's not a this, so what is it? So let's go ahead and break that down for a minute. If all those other things are true, but it's not a human, I'm talking about automation, and I will talk more about that in a minute. If, on the other hand, everything is true, but it's not right now, it's going to happen later, what you're talking about is a report. If all those things are true, but it's not really a problem, then what you're talking about is a dashboard or a view, something people can go look at their leisure. And finally, if no one's going to do anything about it ever, delete it. Once again, you do not get paid by the bushel. Actually, it's more than just a gag. Alerts, more than almost anything else in your monitoring and observability system, represent a significant drag on that system. An alert is basically a query that runs against the entire set of data that you have right now. Are you proud of the fact that you have like 10 terabytes of data or 16 petabytes or whatever it is? Every time you run an alert, it's going to run against that entire data set. If you have 10, 50, 100, 200 alerts, those are queries that are running every minute, every 2 minutes, every whatever minutes against your complete data set. And those are resources that cannot be used in other places. Almost every single time I go to a client and they say, monitoring sucks, it's slower than everything, right? It's because they have 2,573 alerts, most of which don't matter, that are running every minute. So they're running that many queries against all their data all the time. All right, back to that CPU alert. There are 4 common pitfalls that people run into when they're building alerts. The first one is the condition itself. So again, back to the CPU alert. I said 98% correctly sized, but if I have a system where the CPU is running high and also I have more jobs in the processor queue than I have CPUs to handle them on an ongoing basis, and also I see that processes are getting dropped or users are leaving the sales queue or whatever, like all those things, then I have a problem. But you know what? I just defined something that was really, really specific and very actionable. That is not high CPU. So when you're thinking about a trigger condition, you have to think about all the things that feed into not just something that's meaningful, but also actionable. If I told you, oh, CPU is high and also more jobs in the processor queue than there are processors to handle them, and also queries are running long, and also jobs are dropping, you already are formulating, oh, I would elastically expand, I would vMotion over to here, I would add more resources. You already know what you're going to do in response to that problem, as opposed to CPU is high. Dunno. Second, the problem isn't the trigger, it's the time frame. Everyone looks at this graph, and this graph is not as good as the one that Paige was showing this morning. Paige has significantly better graphs that are significantly better at exemplifying these, so go back and watch her talk again because they're much better. But anyway, everyone looks at this graph and everyone knows immediately what the problem is, right? Right there's the problem. No, it's not. That's month-end processing. Or it's because it's elastic compute and it saw that everything was low and it just spun down a bunch of systems, and so everything looks higher in relation. It could be a million different things. You know what we all missed? That. The same amount of distance. But our brains didn't catch that. Our human brains aren't made to understand that. That is why you need a monitoring and observability system. That is where the power of alerting is. Okay? But it's only when you look at time frame. A lot of people build alerts for single point in time. Okay? Again, stupid, simple example. Ping failed. Really? One ping. One ping failed. My goodness. That must be an app. No, it's not. Okay, and yet the number of times I see failures of, unavailable for like a second. So factor in time frame. The third pitfall is using fixed thresholds. Okay, everyone says, well, when it's over 80, when it's over 90, when it's over whatever. The problem is that there is no one threshold fits all. There's not even a one threshold fits most. Better is if you threshold on a baseline. The monitoring system is already collecting information about what that system is doing, what normal looks like. So when you create thresholds, create them as a percentage over baseline. Let's say 10% over baseline. If it goes 10% over the baseline for the system, normal for the system, in a minute, 2 minutes, 5 minutes, whatever your time frame is, then we have a problem. Well, that's great, except when you look over there, you can see that I got a couple of systems where they're never bad, right? If I have a system that's running at a gig, I don't care a gig of what, gig of pickles, a gig of hamsters, I don't care. But a gig, okay, that's its max capacity, and it's running pretty consistently at 700, okay? 700 meg of pickles or hamsters, right? So 10% takes me to 770. Still not get out of bed kind of urgent. Like I might want to deal with it, but whatever. So the best way to deal with this is to have thresholds, fixed thresholds and baseline together. So anything above the yellow line might alert, anything above the red line will alert. When it's 10% above the threshold. A little bit complicated, but much more accurate when you start to build out these things. The fourth trap is having a lack of automation, okay? All right, again, simple example, disk is at 95%, all right? What do? The same thing everyone does. You delete the temp directory. Like, that is what everyone does. And it's fine, and you know what? It works. The fact is that is frequently what the problem is. And so the thing is, why would I wake somebody up to go do that? Why would I make anyone stop what they're doing to do that? Why wouldn't I put a script that responded in response to the alert automatically to delete disk space? And if the problem persists, then I will get a human being to go do something. I did this at one company. I reduced the number of tickets by over 300 and reduced the cost by $80,000. Just that one piece of automation. It can be incredibly powerful and incredibly valuable. So the problem with automation is that people think it's too complicated and it's too involved and I don't know enough about the system and all those things. And it's really, really simple. Go to the person who is getting the tickets. Go to the person who's responsible for the situation. You're building an alert, you've got the trigger, and then just ask them one simple question. When this problem occurs, what do you do? And they will tell you. Sometimes they will say, I just typed the Gafrinkle command, and then it clears it right up, right? There's no Gafrinkle command, don't look it up. I don't want to create an incident here. Okay, so, okay, fine. How about I type the Gafrinkle command and tell you what the output is? Or if the problem doesn't go away, then I will let you know, or whatever. Like, how powerful. Monitoring and alerting bear witness to the moment something goes wrong. There is nothing as powerful as being able to respond in that moment with the exact actions that might repair the situation. Another cool part is that the conversation that proceeds tells you a lot. It is so delightful because you say, all right, what do you do? And if that doesn't work, then what? And if that doesn't work, then what? So you end up with this cascade of joy. All right, so I'm going to take, again, old example, but I'm old, so what do you want? All right, IIS. Thank God we don't have to use this anymore. IIS is slow. What do? The same thing everyone does. You clear the application pool. That is what everybody did. First step. Then wait. Now, what am I talking about? I'm talking about automation. Because it's really easy to issue a command remotely, PowerShell or whatever, and clear the application pool and wait 2 minutes, 5 minutes, whatever. And if the problem doesn't go away, reset the IIS service and wait. And then rebuild from the image. Sure, why not? Or reboot the server in the old days or whatever. And wait. And then vMotion or migrate to a new site or whatever it is that you're going to do, okay? And wait. And if that doesn't solve the problem, then you send a ticket. Then you wake up the human. You bother. You interrupt the human. But at that point, what happens? They've still gotten the ticket, right? Well, first of all those other things might have fixed it. But second of all, when they get the ticket, they know all those other things have already been done. If you're really good, you take the output from all those commands and you stick it in the ticket. They can see what happened in the moment of that. You have effectively launched them forward in time so that they don't have to do those things and they can use a giant, big human brain to actually solve the problem. That takes me to the most important lesson of all, talking to people. Sorry, I know. Nicely, nobody in your company is a homicidal, psychopathic clown, probably, I hope. But you do talk with them with the same determination of the world's greatest detective on the hunt for the killer of my app 123, right? You really want to dig down and find out what was going on, what is going on, okay? The only way to understand about the application is to talk to the people who have the lived experience with it. And so that's why you have to really get in front of those folks and find out what's going on and why. Now, I call this slide the hunt for the great useful alert because the person you talk to first is typically not the person that you need to talk to. As somebody who builds monitoring and alerting, you are going to talk to the requester of monitoring, and you are basically a checkbox that is in the way of rolling to production. And I am here to tell you that those people lie all the time. They will look at you with a straight face and say, oh yeah, this thing is built like a steel rock. It's made out of unicorn farts and angel spit. It's never going to crash. You don't need to monitor anything on this baby, right? They lie to you. What you need to do is find out who's getting that ticket 2 months from now. Get in front of them. They're the ones who will be able to tell you, oh, I see this. Oh, this thing happened. And then you're able to really start to dig into it. And how do you dig into it? I have a few questions that I like to ask that tell me a lot more about how to build monitoring and alerting effectively. First question, how do you know when something is wrong? Hopefully the answer is not the users call me, but that is often the place it starts. But okay, fine, you take that for what it's worth. But a lot of times they'll say, oh, when the users call me, I validate it by typing the gfrinkle command and it tells me blah, blah, blah. Oh, great, how about I build a monitor that types the gfrinkle command every 5 minutes and gathers it, and if it says these bad things, then I know that there's a problem before the users call. How about that? Okay? Second question, how do you know it's all better? A lot of people don't think about this. A lot of people think of alerts as it went bad, and when it's not bad anymore, it must be good. But we all know that there are situations that are bad is up here, but good ain't here, okay? Again, using a simple example, disk space. Sure, disk is over 95% is bad. Disk is 94% is good? No. I ain't calling disk good. It's 3 o'clock in the morning. Disk ain't good until it's below 80% for 20 minutes straight. Then I'm shutting that ticket. Until then, it's all bad, all the time. So fine, have a reset trigger. Have a trigger that reverses the ticket or not closes, reverses the incident. Know what all better looks like and document that and put that into your alert. Is there a knowledge base article for it? Yet, because I do not roll alerts into production until there is one, period. If you want to tell me that the knowledge base article is call Bob, fine. God love Bob. But You've got to have something, because the person who's helping, even the person who is helping build it, isn't the one who is living with it 24/7. So you need to have some article of what to do with that, a run book of some kind. And finally, can you make this happen on purpose? I'd like to see that. Again, doesn't go into production until that happens. Why? Because I was asked to build an alert where a log file said the word error in it. I turned it on. 772 tickets later, we found out that there was a message, no error found. Every half second. Make it happen on purpose. There's a couple of situations where that's not valid, like, I want to detect if the data center is on fire. No. Don't do that. But I mean, joking aside, reverse the trigger when the data center is not on fire. Like, just make sure that you can detect condition along the way. But for the vast majority, I need to see this happen in the wild, because one of two things happen. Either they can make it happen, or it never happens. At that point, once again, an alert is a drain on the system, and I'm not putting that in production, and I'm not doing it. And if they can't make it happen, all right. Another thing about value is businesses run on money. I know this comes as a shock for some of us. I tend to live in a money-free zone. I am one of those people who have never successfully bounced a checkbook. I am 0 for 200 on attempts. Really, if it has a $, my instructions from the company are run like hell out of the room. Like, do not talk about it. Fine. However, companies do care about money. Having something like this, it is not that hard to set up. To say, these are the alerts I have. This is what it costs if I didn't have the alert in place. This is what it costs when I do. Therefore, this is what I save. Having this is incredibly impactful to the business. Okay, disk full, $80,000. Now, you can say that's, there's a problem here. Fine, okay, let's get that number down. I have taken those numbers, gone back to my boss and said, that's 1 month. I would like 10% of that back in my monitoring budget, please. My boss said, well, that's not actually how it works. I mean, it's not really like you're spending the money. I said, oh, good, it's not important. I'll turn off that alert. Oh, no, don't turn the alert off. You end up with some very funny conversations like that. But if you can prove the value of alerting, even if it's just to make a point, you've made a point. Now, a lot of people immediately look at that and say, but how am I supposed to know? Now, in some cases, it's easy. I was working for a healthcare company. They had an order entry system for the pharmacy. It earned, they knew it. Believe me, we all knew it. $167,210 per minute. We all knew that number. That was the cost per minute of an outage. Great. I'm sticking that on that spreadsheet. Right? You want me to monitor that system? You want me to alert when it's down? Fantastic. That's going in there. In other cases, it's much more difficult, and I have a very, very closely guarded secret about how to get to accurate numbers. Wildly overestimate. Believe me, people will fall over themselves telling you how you're wrong. Just say, oh, the order entry system is down. That costs about $9,000 every time for every minute. It's like, no, it's not. It's only $425. Gotcha. Fine. But you will be able to find out how much each alert or each system or each situation costs eventually. But having that, really important. Okay, so let's sum up. We have identified and interviewed our subject and found out the recipient of the tickets to find out what's important to them. We have designed an alert that matters because it has real-world triggers. A real-world trigger on elements. It takes duration and baseline into account. It includes automation. And we have verified that the alert is built with the intent of immediate action by a human, and we have communicated the value of this alert to the business. Fantastic. We're done, right? No. Last lesson is the shortest, but it's also the hardest. I am sorry. The idea is that once you build an alert, it's not done. You have to go back, whether it's quarterly or every 6 months. You go back to the recipients and check in with them and find out how it's working for them now. Because the situation changes. Is the traffic that we expected or we first saw in the application the same as it is today? Have we maybe migrated it from on-prem into the cloud and therefore everything is completely different? Have we done, has the application become more popular, less popular? Has something replaced it? The situation changes. The teams change. The priorities change. We change. But the work remains the same. But far from being a punishment of having to now go back every time, as somebody famously said, no is temporary, yes is forever. We just said yes to the alert, so now it's forever, we own it. It's not really a punishment. It actually is recognition that you have done something well, because believe me, if the alert sucked, they would never call you. They wouldn't want to hear from you. But if it's doing well and they welcome you back, they will not only welcome you to continue to make it better, they will give you more ideas and more things that are actually wrong so that you can do the work of removing friction and toil from their world. Congratulations, you made it to the end, you win a prize! This is completely free. You can get the TCP/IP hat just by scanning a QR code. I will wait here actually hold that thought for a second. But meanwhile, if you feel irritated, I did warn you that could happen. At this point, you may want to take the things that I said and begin to mull over them and layer them with your own experiences to see what results from it.